All right, let's go over today's Check Your Understanding. It says a community activist group in Austin, Texas wanted a particular issue to be placed on the ballot of the upcoming election. To make it on the ballot, 20,000 valid signatures were needed. The group turned in their petition with 24,598 signatures. To pass the validity test, 81.3% of the signatures must be valid. It is too time consuming to check all of the signatures, so a random sample of signatures are checked. The individual checking the signatures needs to be 95% confident that the true proportion of valid signatures are estimated with at most a 2% margin of error. So part one says, using a conservative estimate for p hat, how large of a sample is needed? Okay, so how large of a sample of our 24,598 signatures do we need to make sure we get the correct validity? So this comes down to our margin of error. And we're going to set that equal to, we know that the margin of error is equal to our critical value, Z star, times the standard error, so the square root of p hat times 1 minus p hat divided by our sample size. So let's plug in some values there. I know that my margin of error needs to be at most 2%, so 0.02. For a 95% confidence interval, I need a critical value of 1.96. And then for my p hat, because it's asking for a conservative estimate of p hat, I'm going to use 0.5. 1 minus 0.5 divided by my sample size, n is what I'm looking for. Okay. So just pointing out where all of these numbers came from, my 2% margin of error, my 95% confidence interval, and my conservative estimate for p hat. All right, so then solving for n, okay? We start by dividing out the 1.96, so I'd have 0.02 divided by 1.96 equals what's under the square root, okay? To get rid of that, I'm going to square both sides, okay, which leaves me with 0.25 on this side, and ultimately I can get n equals 0.25 divided by 0.02 divided by 1.96 squared. Okay. And that's going to give me a value of 2,401 signatures that I need. Okay. A word of advice, I personally would work this in my calculator step by step. So I start by taking 0.02 divided by 1.96. Then I would square that answer. Okay. Then I would do 0.25 divided by whatever that answer was. Okay. Just because it makes everything a little bit easier, not rounding things, just pushing it through my calculator. Okay, so part two. In the activist group's previous petition, 85% of the signatures were valid. Using this value as a guess for p hat, find the sample size needed for a margin of error of at most 2 percentage points with 95% confidence. How does this compare with the required sample size from question 1? So now we have a p hat. Instead of using a conservative estimate, we can use this 0.85. So same setup, we still have at most a 2% margin of error. We're still using a 95% confidence interval, so critical value of 1.96 times the square root of, now we're going to use 0.85, and 1 minus 0.85 is 0.15 divided by n. So solving for n equals 0.12 1275 divided by 0.02 divided by 1.96 squared. You should get 1,224.5. And since we can't have half the signature, we're going to round up to 1,225 signatures. Okay. So make sure that you're thinking in terms when you're finding the sample size, you always round up, okay? Because we can't have that piece. All right, so we have to remember to do this last part. How does this compare with the required sample size in question 1? Well, much smaller, okay? The sample size is much smaller, and that makes sense, right? We have better validity, and so it's going to take fewer samples to get the result we want. Okay, because that sample size is down in the denominator of our fraction. All right, what if the company president demands 99% confidence instead of 95% confidence? Would this require a smaller or larger sample size, assuming everything else remains the same? Okay, so your answer should be that we need a larger sample size to be more confident. They must check more signatures. All right, so there is kind of that second standard that we, our second learning goal for the day. If you have more questions or need some more help with the math, please ask questions in class.